0% chance.
It's worth a shot.
Negative 0. If that's math.
Dude, there can be negative 2.
It's a thing. It's a thing now, Colby. Today is the 11th of the 10th month. Yeah, it is. I know. It does mean that. Good job, Sam. So we're going to just practice today one set skill, and it'll probably be a 2-day skill, but I'm not entirely certain. We'll see how today goes. So what we're learning today is factoring. Quadratics. Again, I'm not going to toy with you. We're not going to take this next level. We're not going to go up to like lookalikes and all these weird things. We're going to stick to just normal quadratics.
This format, like,
Yes. Yes.
We worked on this for like 6 months last year.
Yes. Well, it wasn't 6 months. That was a bit of an exaggeration, but yes, you've gotten a heavy dose of this before. Yes, this should be. I'm already throwing this out. If anyone needs any help, not free answers, but help with the concept, Sam's probably going to be your guy because he got a lot of this last year. So good.
Did you say 3 answers?
Yeah, don't get free answers. Like Sam's not going to be Sam's not going to be giving out answers or selling answers. Sam's going to be helping people to understand how to do it themselves. Right, Sam? Right, good. So here's the goal. If you don't know what factoring is, or if you don't remember, it's this. Here's a multiplication problem, which I am purposely leaving blank. And I'm going to tell you that the answer to the multiplication problem is x squared plus 8x plus 12. So factoring, just so you know, it's a word that you've actually been doing since like 4th grade. To factor something means to figure out 2 things that multiply to make something else. So like back in grade school, your teacher might have said, okay, class, we're going to find, like, remember the little trees you used to make back in the day with, like if your teacher put up like 24, how you'd have to make a little tree and put like 2 numbers that multiply to make 24. That's called factoring. That's finding things that multiply to make something else. So this is obviously just factoring on a much grander scale. So the reason we did polynomial operations before this is obvious, because this would make no sense if we hadn't multiplied polynomials first. So what we're doing today is we're unmultiplying them. So my task for you, and Sam's not allowed to play in this part, so anyone else, my task for the other 16 of you is this. Could you write me a multiplication problem whose answer is x squared plus 8x plus 12? What would it
I
be?
have to think about it.
I have to think about it.
Wouldn't it be x
Or x to the 2. X plus 2 times. Yeah.
What do you think?
Times that. 3 plus that.
No, it's
84.
no, it's that. You asked like what two numbers you add.
I like something that Colby said, and I actually thought he was going to take us all the way home. So I'm going to put down part of what he said, because quite frankly, it is part of the answer. Plus times what, Brandon?
One would be like plus 6 and 4 plus 2.
Is it
It doesn't matter which
It'd be
one.
4 plus 6.
3x plus 4?
No. Yeah, no, it's not like you're just gonna take the opposite and you're gonna put it in the other one. Like you're gonna take x plus 4 plus 6, or like, what times?
I don't really know what just happened to our conversation. I think we might have devolved. So let me make myself more clear. I've underlined something on the TV. I'd like you to help me just fill in what that has to be. Like, I mean, this is, again, a much more high schooly version of this. If I said to you, okay, something times something equals 40. And Colby said, okay, 8. Then you guys would just go, oh, this has to be 5, right? Because 8 times 5 makes 40. So all I'm simply asking you to do, and I say simply, I shouldn't say that because it's not simple until you know how to do it. I'm asking you to find the other half of the multiplication problem whose answer would be x squared plus 8x plus 12.
X plus 4x.
Nope.
Oh. Like you didn't.
You feel like my question so far has been
No,
poorly
yeah,
phrased?
The top way different.
I teach it different every year. It's the only way to
Last
keep
year worked.
myself fresh. Don't worry, it's coming, Sam. Don't worry.
4 plus 6.
I heard someone say x plus 4, and that's not right, but I'm at least finally a good, committed, sensible answer. So let's go back to something that we've practiced before, and this will make sense. Not maybe right away, but it will. Before you leave today, you're going to be pros. So if I wanted to know if this, but good teamwork, everybody. It was a little clumsy, but we got to someplace. Now, the idea is if I want to know if I factored correctly, I just multiply it back out. And you all aced the test on this. So I know for a fact you can handle, I'm going to color code the living daylights out of this. So here we go. Remember when you do FOIL? Remember FOIL, how we multiply everybody by everybody? So here we go, help me out. And don't come jetting in with the right answer when you figure it out. Let's finish this task. Okay, so we know that. Now let me switch colors. Let's go here. What's that?
4x.
Good job. And I'm going to switch colors again. What is that?
2x.
Okay. And then what is that? Okay. So if we want to know how we did, we can always check our own work to see if it comes out to equal x squared plus 8x plus 12. And I don't mean to talk down to you, but I mean, it's not going to work, right? You can see that it's not going to work because if I combine those two like terms in the middle, how many x's do I get? So I got x squared plus 6x plus 8. And clearly I was trying to get x squared plus 8x plus 12. So this is a fail. But that's okay. That's part of the process with factoring is failing and then realizing why you failed. And so let's go back to the drawing board and let's put something else in that second spot. You're not allowed to play, Sam.
I have a question.
Sure.
So what if we cross out the 12 and then all the things that will apply to the 8?
They don't multiply to make 8.
We're keeping X plus six plus.
But add,
I don't know, Kale. Do you think it would be?
we crossed out.
We're
the
keeping
X.
X plus six too.
Let's try x plus 6. Don't worry, it's a much more scientific process than this thing we're doing now. It's not, I'm just trying an approach here to see. I always just throw things at the wall and see what sticks, and who knows. So for now, let's see if what Kale said is sensible or not. So let's go back again. I've already got my little color codes there. What's red times red?
X squared.
Okay, what's blue times blue?
X.
Plus 6x. What's green times green?
Right.
And what is yellow times yellow? Combine your like terms, what do you get? You get x squared plus 8x plus 12, which I'm pretty sure is what we were going for. We did it. It took a long time, and it won't always take that long. Good job, Kale. But that's the process, is we're trying to find the multiplicative factors that when multiplied make a given answer. I'm going to put another one up here in case anything clicked in your brain when you see that answer. You might think, I could do this. I'm going to put up another one and let's see if it doesn't take us 5 minutes. So that's what factoring is about. It will become more scientific, I assure you. Let's try x squared plus 11x plus 24. So what we're doing is we're breaking it down. You're going to hear me refer to these empty parentheses as shells. They're actually just empty binomials, but I call them shells because that's what they feel like to me. You already got it, Chance? Holy crikey, son. Some of us haven't even figured or stopped writing it down yet. I'm coming to you first, though, Chance. I'm going to give everyone a few seconds to let this marinate in their brains. I'm ready for you, Barth. What do you think it is?
The X.
Yes.
Fancy you little mathematician.
Good job, Chance.
You've been doing your daddy down, huh?
That's a good one.
Try this one. Did you get it? Jillian, would you like to share with us what you got? Yeah, nice job. Don't worry, I'm going to totally show you like literally how to do this. I'm just curious to see what you guys are absorbing on your own here. Nice job. Kale, you okay, bud? Okay. Let's take a look real quick at why the science is working the way it is. So first off, let's talk about this. What is x times x? Okay, so throughout today and tomorrow, as you hear me talk more about these, understand that I'm not going to give out a lot of gold stars for figuring out that x times x makes x squared. That's something that we're just not going to negotiate or miss ever. And we're also not going to get a lot of gold stars for this yellow one. What's 1 times 4? 4. If you're listening right now is a really important minute for you to listen, like really important. Again, no gold stars for the red and yellow connectors. That's stupid. That's like 4th grade crap. You agree? This isn't about that. This is about that mysterious 5x in the middle. What we come to know him as the middle term, and it's the one that is the most difficult to achieve. And quite frankly, the reason it's difficult is because you don't control that. Jillian had full control of putting an x and an x to make x squared. And she had full control of a 1 and a 4 to make a 4, right? That was easy. She didn't struggle with that. But where we earn, I'll try to be consistent with my colors here. Where we're going to earn our keep is on the green and the blue. And you're going to see me draw those a lot. And you're going to see me draw them underneath, and I'll try to remember to use the same colors. The green and the blue are the key. I realized in Algebra 2 that I've had students that made it all the way through Algebra 1 and never heard this. And I'm the only guy that taught them algebra, so that's on me. It's all about the green and the blue. So when you multiply the greens, and again, Jillian wasn't in control of that. She knows what she's doing, but she wasn't in control of the green. What does the green make? It makes 1x, right? And what does the blue make? So if she's got a 1x that just happened and a 4x that just happened, and she adds those, what does she get? Jackpot. So you see, we control what we put in the front of the shells, and we control what we put in the backs of the shells, and then we cross our fingers and hope that the green and the blue will add out to equal what's in the middle. Is it as easy as just saying, oh, I need 2 numbers that multiply to make 4 and add to make 5? No. It will be sometimes, but don't make that your rule. Yeah.
So.
Yeah, and don't think that way. That's what I think I was just saying is don't do that, because as soon as these get harder here in about 5 minutes, that's not going to work anymore. So stick to what I'm saying. I choose my words with this. The red and the yellow are easy. It's the green and the blue that we're just kind of like, I hope, right? All right, let's go. Good job, Jillian. Let's go again. I'm going to give you one more, what I perceive to be an easy one. So I hope that you click on this one. I hope that that thing I was doing with the red and the yellow and then the green and the blue makes some kind of sense to you. I'm going to interrupt a little bit just to make sure no one does anything stupid. I'll come right back to you, Sage. We have to all agree, and I'm not saying we should. I'm making an order. You have to agree that that's going to work because x times x is okay. Yay, we got it. Good. But then what happens now is this yellow product has to equal a number. And there's only one number on the board right now that I give a hoot about, and it's the 36. You shouldn't even be thinking about the 13. Right now, I'm thinking about, thank God I had a 4th grade teacher who taught me my times tables. I'm thinking of all the numbers that make 36. I could do 1 and 36, stop that. I could do 2 and 18, 3 and 12, 4 and 9, or 6 and 6. What did you come up with, Sage? Let's take this for a test drive. Now, the only thing that I know for a fact, and again, I'm not handing out badges, little cute trophies for this. The only thing I know so far is that we've accomplished the simple stuff. If you look at my red connectors, yay, we got x squared. And if you look at my yellow connectors, it's like, yay, we got 36. But again and again and again, you're going to hear me say, I don't control the other aspect of this. The green is going to be what it wants to be. What do those make? Nice. And the blues are going to be what they want to be. And what's 9x plus 4x? Jackpot. I hope that makes a little bit of sense because now they're going to start getting a little bit harder as we go. You ready? Okay. You'll notice that so far there hasn't been a single negative, so that's going to change now. So let's try x squared minus 3x minus 10. I already know the answer looks like this. Now go big brain mode here. Think hard. You're not going to just brainlessly put plus something and plus something. That doesn't make any sense because they got to multiply to make negative 10. What do you have for me, Brandon?
X plus 2, X minus 5.
Let's check the basics first. We always, as a teacher, the first thing I do when I grade these is check, did they do anything stupid right out of the gate? We got the easy covered, yay, x squared. And let's make sure first and foremost that Brandon made a negative 10, which he did. 2 and negative 5, yay. Now we check the hard part. What do the greens make? What do the blues make? And what's 2x minus 5x? Jackpot. You understand that one of them had to have a plus and one of them had to have a minus like this and like this because they multiply to make negative 10. And the only way to multiply to make a negative is with one of each. Sure, man. What an excellent question. You mean like maybe like this next problem? Kind of like this, Bryce? I'm going to go ahead and put that much down because I know that that's happening. And Bryce asked a question that I almost feel like I would have paid him to ask that because that's the perfect moment at which to ask that very question. The number in back is a plus, but then the number in the middle is a minus. Kind of witchcraft is this? What's the only way this is going to work, Kobe?
Negatives.
Say, Kobe? 2 negatives, right? It's the only way it can happen. Go ahead, Kobe. I'm ready for you. Let's check. Obvious, jackpot. Obvious, jackpot. Again, no awards for the stupid stuff. Let's check Kobe's handiwork. What do the greens make? What do the blues make? Negative 3x, negative 9x, jackpot. Okay. These ones you can do in your head. Are you ready for the next level? How do you do it in your head?
I still don't know how to figure it out.
Okay. So let me do another one, and this time rather than waiting, I'm just going to walk you right through it. Sound good? Okay. Sorry about that. Let's do like x squared minus 4x minus 21. So are you okay if I put this much? Are you comfortable with that? So like you're totally on board that I need these red guys here to make x squared. Okay. So I'm sorry that I didn't clarify this. Let me slow down a little bit. Your next objective, Kale, the only thing you should, by the way, you all might want to listen if you're even a little iffy. The only objective you have right now is to multiply to make that negative 21. That's it. I scribbled that out for a reason because I don't want you looking under there. So all I care about right now is that you and I are going to pick 2 numbers that multiply to make negative 21. So if it's going to multiply to make a negative 21, then you know that that means that one of them has to be a positive and one of them has to be a negative. You agree with that?
Yeah.
And what are the 2 most common numbers that come to mind when you think of the number 21? If you have weak times tables, you will feel the real massive burn here in this class for a few days. And I'm sorry, I can't fix that. I have to assume by 11th and 12th grade that you guys know. So I'm sorry if that's not the case, but you should be thinking of 3 and 7. 3 times 7 makes 21. You okay?
Not really.
Let me pause my recording real quick. I want to show you guys something. So we're back to this, and all I'm trying to do is put numbers in these two empty spots that make 21. I don't worry about the fact that it's negative because I already got my positive and negative sign. So we're good. So let's just say that we guessed that we should do a 7 and a 3. Are you okay so far?
Yeah.
So this really drives the point home that doing the red and the gold doesn't earn you squat, because we have passed the red with flying colors, x squared, yay, and our yellows make negative 21, yay, but what does green make? What does blue make? And what is 7x minus 3x? And I didn't want 4x. I wanted negative 4x. So all you ever do when you get the right number with the wrong sign is you switch the plus and the minus to a minus and a plus. And now you see that the green makes negative 7x and the blue makes positive 3, and they add correctly, right? Does that make any sense at all?
Yeah.
In order, you want to build the red, then you want to build the yellow, and then you want to cross your fingers and hope that the blue-green combo works. Good? Okay. This is why I'm very quick to cut people off. If you ever come up with that rule that, oh, the numbers that we pick have to multiply to make 90 and add to make 17, you will be the world's worst factor. It doesn't work. And who's new? The 3 is an unwelcome intruder. You're like, whoa, we were just getting in a groove here, 3. Get out. That changes a lot, but let's begin with, yes, Colby, let's begin with this, our shells. And I'm with Colby on this one, that by the way, if I just brainlessly hopped in and put this, I failed, right? Because x times x doesn't equal 3x squared. That's crazy talk. So what I'm going to do instead is say, you be a 3x and you be a 1x. And now when I connect those, I'm like, yeah, jackpot. I'm on my way. Tell me about my signs. By now, at this point in the lesson, you should know they're both positives because they multiply to make a positive and they add to make a positive. Well, signs point to positive. All I need from you guys right now is this. I need 2 numbers at the end. By the way, it got a lot harder just now, so watch out. I need 2 numbers at the end of the yellow rainbow thing that multiply to make 90. That's all I ask of you right now. Quick, go. Give me a pair. 9 and 10. So you would agree that the red, we passed with flying colors, the yellow, yay, we're good. That's not what this is about. Let's check green. What's green make? What's blue make? Start again. 30x, thank you. The green is 9x, the blue is, you're fine, the blue is 30x, and when you add 9x and 30x, you get 39x, and you go, well, that was terrible. So that doesn't necessarily mean that the numbers that we're looking for aren't 9 and 10. It could potentially mean that they're just in the wrong order. So maybe let's try putting a 10 here and a 9 here. Now, again, I'm not checking red. I'm not checking yellow. For God's sake, that's easy. That's 4th grade. I'm checking green and blue. What's green make? What's blue make? 27. What's 10 plus 27? Too big. It ain't 17. So we can now safely say 10 and 9, you can show yourselves out.
So can we make it? So then when it's putting together.
No, the signs are going to be very predictable because think about this. They have to multiply to make positive 90. And the only way is either a positive times a positive or a negative times a negative. And they can't both be negatives because of that. You agree?
Yeah.
Once you figure out what your signs are, that's pretty much a non-negotiable past that point. You might have to switch plus minus to minus plus, but that's all. So I think we can say 9 and 10 are dead to us. You agree? Okay, so look at your table. That's the reason I gave you that piece of paper. This will make our next week a lot nicer together. Give me another pair that make 90.
15 and
38
6.
and 3.
15 and 6. What's wrong with 15 and 6? Let's try 15 and 6. And so if I put 15 here and 6 here, what do I get? Yeah, I get 15x for the greens and I get 18x for the blues. Add those, you get, what is that, 33? Too much. Okay, and obviously if we switch them, it's going to go bigger because the 15 going to the far side pairs with the 3. They're like, yeah, it isn't going to work. What else multiplies to make 90? Okay, let's try 5 and 18. I wonder if oh, you know what I did? Oh God, you guys are gonna, don't get mad at me. Promise? Brandon? Yes. I messed up. This is, I knew this was, I'm going, this isn't gonna work. So everybody, here's what I want you to do. Are you with me? Are you with me? You see this plus sign where I'm hovering with my eraser? Kill it. Change it to a minus. If that's the worst thing I do all day, it's going to be a good day, but it's still my bad. So now I can also get rid of my plus and turn them into a plus and minus.
The 10 and the 9 would work.
No, you were right.
How are you gonna get 17?
Let's put a 10 here and a 9 here. Let's see. I'm really sorry that I messed that up, but experiences like that are good for us. They keep us fresh. That's my story. Anyways, let's see now if 10 and 9 might work now that your teacher put the problem correctly on there. I don't even know what I was thinking. What do green make now? What does blue make? What's 10 minus 27? Did I want negative 17? So switch what? No, only the signs. If you switch the 10 and the 9, it's game over. You're going to miss it. If you have everyone right where you want them, then just change the plus and minus to a minus plus. Now, what do the greens make? What do the blues make?
27.
What's negative 10 plus 27? Jackpot. Next one. I promise I'm going to copy this one down right. No, there's no hope. I promise.
We get into the cube.
We will not be doing any cubes. No cubes, no lookalikes, no nothing. Just we're quadratics this year. That's all. I'm going to give you guys a moment, but I would like some help getting started with my shells. What do I know goes at the beginning of my shells? 5x and 1x. And can you tell me? No, it doesn't. What matters is like who goes in the same cell as the 5x. That's what matters. So like it can be wherever. Tell me about my signs. If you say negative and positive, then I am failing you right now because they multiply to make a positive 2. And the only way to multiply to make a positive is either with a positive times a positive or a negative times a negative. I know that that's the part of this lesson that I suck at the most. Look at the number in the back. If it's a positive, there will not be one of each. And I heard Colby say it. They both have to be this.
Will they just be negative 2 times?
Like,
Come around.
is that okay like that?
Yeah.
Let's see if it works. It seems like this should obviously, it seems like this should obviously be the answer because you're like, well, duh, there's only one way to multiply and make 2. It is. So if you check your green, what do you get? Check your blue. -1 and -10 make -11, but I heard you guys all jump all over me. Thank you for that. I just clearly have them in the wrong place. Instead of 1 and 2. Now what do the greens make? What do the blues make? Check. There's one more level of difficulty. Are you ready? Okay, you still with me? It's a lot to sit through. I got one more level. I'm leveling you up now. Okay, we just defeated a boss and we're on to the next level. Did you just sigh disapprovingly at me, Luke? And I never know if people, after 27 years, you don't know, are people going to answer this question correctly or not? But I ask it all the time. Do you know why this one is so much harder than its predecessor? No, I'm not going to screw with you anymore. This that was accidental. What has two factors? Yes. So in that last problem that I gave you that started with a 3, you knew that it started, or 5, whatever, you knew it had to be like 5 and 1, because 5 is a prime number. But the 6 can be made more than one way. And this is when factoring is officially now at its most difficult, is when I look at it and I build my shells like this. And then I go, well, it's got to be this, right? And then I sit here and I go, okay, I know it's a pair of pluses. And then I realize, oh, snap. It also could be this. You follow? So when that number in front is something non-prime, like 6 or 8 or 9 or 10, then you realize, ooh, there's more than one potential like workspace. Where? I mean, the only way to make 6x squared is either 6x times 1x or 3x times 2x. You agree? So these are my workspaces. And what numbers come to mind when I tell you I need you to make 35? Yeah. So which template, top template or bottom template? Okay, so let's go to the bottom template. And if it doesn't work, that's okay. We'll go work on the top template. And you said 5 and 7? So like this, 7 here, 5 here. So are you already telling me this doesn't work? You guys are bossy. Let's try it this way. 5, 7. And I'll keep using the colors, but you know what I mean. What do the greens make? What do the blues make? What's 10x plus 21x? Jackpot. You ready? I'm going to stop the recording. Your assignment today is either in Delta Math if you can get on, or if you can't, then I have a worksheet back up that I want you to do. But I need you working on factoring. So that's that. Yes, guys, it's in the Daddy Delt.